This is Pre-Calculus Concept 34A. We're going to talk about something kind of new and different called the law of sines. Some of you may have studied this in your geometry class, but it also fits in well here with the trigonometry we've done recently. So the law of sines here is shown below, and what's really cool and useful is that the law of sines works for any triangle. So you may remember the SOHCAHTOA that you've used many times for trig problems. That only works in right triangles, and so if you are presented ever with a situation where you have a non-right triangle, law of sines is one of the first things that you're going to think about. So here's what the law of sines says. In a triangle ABC, we're going to think of A, B, and C as the vertices of the triangle, and so obviously I have three angles, angle A, angle B, and angle C, and we're going to call the sides across from those angles by the same letter, but it's very important to not confuse those. So usually we have a capital A for the angle and use the angle symbol, and the side across for it's going to be a little lowercase a, and I use a different color here just to emphasize that. So the sine of angle A divided by A ends up being a ratio, and it turns out to be the same regardless of which angle you choose, provided that you're always doing the angle and the side across from it. So you may very well have a triangle that's labeled differently with different letters. Maybe it's not even labeled at all. But what you can remember is that if you take the sine of an angle and divide by the side across from that angle, you will always get the same ratio. Where this becomes particularly useful is if I know 3 out of 4 things, you can always figure out the fourth. And that's basically what we're going to see in our examples with law of sines. Take a minute, jot this law down. It's a formula we expect you to memorize and know. This is also a good time to grab your calculators because we're going to do a bunch of work that require use of your calculator. Okay, here's an example. I've got a triangle there shown below. If you think about the sides and the angles together, you actually have a grand total of 6 things in the triangle. And in this particular problem, I'm going to give you 3 of those 6 things. And it turns out we can figure out all of the rest pretty easily. So I'm going to go ahead and add these to my diagram. Angle A is going to be 50. Angle B up here is going to be 106. And side C, which remember is across from angle C, is going to be equal to 3. And our job is to basically solve the rest of the triangle. So let's start off with angle C. Well, hopefully you remember that angle C plus angle A plus angle B, 106, all have to add up to 180. So that's a pretty easy calculation to do. I'm going to subtract those 2 angles from 180, and I get 24. I always like to check to make sure, relative size makes sense. So, that looks like a pretty small angle, and 24 is a pretty good outcome. If you ended up with, 150, and you looked up at the picture and saw it was a small little acute angle, then you might know you did something wrong. Okay, I'll add that to my picture now. I have all 3 angles figured out. Just knowing 2, I can always find the third. Alright, finding B. Let me do this in a different color. So the length B, notice, is across from angle B, which I know. And then I also know another angle side pair, that being side C and angle C. So here's what I'm going to do. I'm going to set up the law of sines. I know that the sine of angle B, which is 106, divided by the side across from it, which is unknown, has to be the same as the sine of angle C, which is 24, divided by the side across from it, which is 3. So again, I have a proportion there where I know 3 of the 4 things, and I should be able to solve that. Okay, let's go over here to the side, and I'll do cross multiplication. Gives me 3 sine of 106 equals B sine of 24. And if I want to find a formula for B, it's going to be 3 sine 106, 106 divided by the sine of 24. Okay, here's where I want to take my calculator out. Since my angles are in degrees, alright, we haven't seen degree measure a whole lot lately. You do want to make sure you change your mode on your calculator. Plug all those numbers in, and you end up with a 7.09 answer. Okay, and finally I have side A. I'll do this in a green color, and I'll do it a little bit faster, but the same thing is going to be true. The sine of angle A, which is 50, divided by the side across from it, which is unknown, A, has to be the sine of 24 over 3. Okay, if I do some cross multiplying and calculating on my calculator, A turns out to be about 5.65. These are generally long decimal answers, so we'll usually ask you to do one or two places. But so starting with three things at the beginning here, I was able to figure out the other three parts, and I now consider the triangle solved because I know all of the parts. Okay, in that last scenario, we looked at basically angle, side, angle. So if you know an angle, a side, and another angle, and the side is between the two angles, then I can solve the triangle. Same thing turns out to be true if you know side, angle, angle. So it's a different combination of stuff, but I'm going to start by writing in my values here. I know side A, I know angle A, and I know angle C. And the question is to solve the rest of the triangle. Let's do this a little quicker. Side B is just going to be what's left over from 180 when you add those two things together, so that turns out to be 105. I'm going to set up the problem and assume that you can figure it out. If I want to find side C, let me do this in blue. Side C would be the sine of angle C divided by side C equals the sine of 55 over 10. Just one thing about setting these up, you always need one angle side pair that you know in order to figure it out. I'm not going to save some time on the calculations there, but C ends up being 4.18. And then finally, the last missing piece here is side B. So I'm going to look at angle B, which I just found above, and say that the sine of 105 over the side across from it, which is B, is going to once again be this ratio that I know, sine 55 over 10. Right, and B in this problem turns out to be 11.79. Make sure you are able to get that on your calculator. Okay, so once again, starting off with three things, in this case side, angle, angle, I can find the other three pieces. Turns out you can't always do this, but if you have the last two combinations, angle, side, angle, and side, angle, angle, you can always use law of sines to solve the triangle. Okay, let's try. You try. I gave you three things up here. See if you can draw out a triangle, maybe label those three things, and then the goal in this problem is to find side C. So rather than solving the whole triangle, just find that one length. Take your calculators out, give it a try, round your final answer to 2 decimal places. Okay, a couple key aspects to solving this problem. I think it helps to draw a little triangle and label the information. Part of this problem was you had to find the third and missing angle, so that should have been 18. And then the second part was realizing that you needed to use the law of sines. Sine of 62 over 12 is an example of a angle and opposite side that you know, and sine of 18 over C is how you bring C into the problem, and then putting all that together and solving for C, the final answer is 4.20. I'll also talk in class about where the law of sines comes from. It takes a little time, but it's kind of an interesting derivation on where the formula comes from.